Okay, hi everyone. Today we're going to solve this LeetCode problem 2483, minimum penalty for a shop, and it's the third problem from the bi-weekly 92, and it's a fairly easy problem as compared to the previous third problems of these contests. And let's see what this problem is. So you're given the customer log visit log for a shop represented by the zero indexed string customers consisting only of characters n and y. If the ith character is a y, it means as a customer comes at the ith r, and where n indicates that no customers come at the ith r. If the shop closes at jth r, the penalty is calculated as follows. For every hour when the shop is open and no customers come, the penalty increases by 1. For every hour when the shop is closed and customers come, the penalty increases by 1 again. Now we need to return the earliest hour at which the shop must be closed to incur a minimum penalty. Note that if a shop closes at jth hour, it means the shop is closed at the hour j. Fine. So yeah, this is an important line which I want you to consider. So j could be equal to 0, right? So j could be equal to 0 and all the way to n, which means that if we are given a string size n, then we are only presented with the for example, if we are given an n size string, then we are only presented with 0 to n minus 1 hours, but we also have the nth hour. Because of this line, you can also easily make this observation that it's also equal to n, and at this hour the shop will be closed. The shop will automatically be closed, right? At this hour, this is like the closing time of the shop, and it will be closed regardless if there are customers or not, how much penalty it will make, it will be closed. Fine. So this is the thing. Now let's understand it by running on some test cases. So we have y, and y, and 0 1 2 3. Fine. So at this point, let's say that I want to, so at this point, what does we mean by y? So at this point I will say the shop and there are customers, right, in this shop. So this is a shop and there are some customers in this shop. At this hour there are some customers again, but at this hour the shop is empty, and at this hour the customers are there again. So you can easily observe that how the penalty will occur. So let's say I am at this hour and I choose to close this shop at this hour. So I will say that the customers who are present at this hour will be disappointed, and because if a customer is disappointed or there's some, let's say, a business loss, then we have a penalty. Then we have a penalty for it. So obviously it will be a business loss for what? For like how many penalties will be there? So first one, the current customers will be giving a business loss, which is a one penalty, right? Then these customers who wanted to come at first hour will be disappointed to see that the shop is closed, and this will be another penalty. And at this hour there will be no penalty because there are no customers, because none of the customers are coming at the second hour, but at third hour there are some customers coming and it will cause the last penalty, right? And we also have n at 4, and it will not cause a penalty because the shop is closed and none of the customers are coming at fourth hour. Fine. Which means that at 0 we will have the total penalty of 3. Fine. So if I choose to close the shop at 1 first hour, then I will have the penalty of 2, because the present customers and the customers who were coming at third hour will cause a penalty. And if I choose to close the shop at this second hour, will cause a penalty of only 1. Why? Because only the customers who were coming at third hour was seeking for the shop to be open, but it's closed, and it will result in a penalty. And if I close the shop at third hour, it will again result in a penalty for the current customers. And if I close the shop at fourth hour, now at this point, this is interesting, this will also cause a penalty. Why? Because if I close the shop at this hour, now the shop is closed, right? Which means from 0 to 3 it was open, right? The shop was open from 0 to 3, and if it was open, then customers were coming fine, but at this point it causes a penalty because none of the customers were coming, but the shop was open, which means this is a one penalty, and this is also fine, and this is the, and at this point we also have, we are not going to have any penalty because we closes the shop at 4th hour, and there are no customers because it's n, there are no customers, so the penalty is 1. Now I want to return the minimum penalty, so out of these the minimum penalty will be 1, and the first index that I will encounter the minimum penalty is 2, so my answer will be 2, and 2 is the answer. Now let's see another example, that is n, okay, 5 times, and last n as well, so 0, 1, 2, 3, 4. By the way, this is not present in the test case, I'm constructing it by myself just to give you a clear representation of how this what the problem is. Now if you choose to close the shop at 0th index, 0th hour, now there is no one, there are no customers who are coming at any hour, so it will result in 0, and similarly for every hour it will result in 0 penalty, right? For every hour it will result in 0 penalty. For all these values the minimum value is 0, and the 0 initially you will collect the 0 from the 0th index, the minimum penalty from the 0th hour, so answer is 0. Now let's see another last example, and we have y, and y, right? And 0, 1, 2, 3, 4. Okay, so this is by the way the constructed one. And now at 0th hour, how many penalties would be there? This customer will be disappointed, they will be disappointed, they will be disappointed, and these. So there is a total of 4 penalty. And at first hour, how many penalties would be there? 1, 2, 3. So there will be penalty of 3. And then at second hour there will be penalty of 2, and at third hour it will be a penalty of 1, and at fourth hour, so at this hour, this means this is closed now, and all these are, it was open, and when it was open there was none of a situation where none of the customers came, which means that there is no penalty, which means we have 0 penalty for the last hour, fourth hour, which is why I was constructing this case, because in some of the cases like this one, or let's say some other case where we have the penalty for this one is not on the open hours penalty is not that big, is big enough than the last penalty, so this will be the answer for the last R will be the answer in that case. So in this case the answer will be 4th, and this is answer, and this is our answer. Now let's solve this problem. So I think we are clear with this now, and you can see that if we are on the ith index, we need to have the values at ith index, we need to have the forward values of y. How many forward values of y are there in the string? And if the value is n, then we need to have the backward value, that is a backward value of the character, right? Yeah. So let's solve this problem now, and I think you can easily see that it's more like a prefix sum problem, because prefix and suffix sum problem, because we are checking the in front value from the ith index. We are checking the value of I plus 1th index, starting from I plus 1th index to nth index, and similar we are also checking, depending on the case, if it's a y or n, we are also checking the value from 0 to I minus 1th index, right? Which makes it a problem of a simple prefix and suffix array, right? So let's solve this problem. The first thing is we need to augment the string with the last r, and that is n, right? Then we will have the, so let it be c, and then we will have the size of the string, and after that we need to construct our answer. Actually we don't really need answer, so let's not have it. And then we want to construct our, now this is the open penalty vector, fine, and it will has the size of n, and this is the close penalty vector, and it will have the size of n again, and then we have total penalty and it will have the size of n. Now open penalty of starting character will depend on this. If the starting character, if in the customer string, and if this first at 0th hour we have, let's say we have no customers, right? So it will say that we have a penalty. So what do I mean by that? So for example, at this case NYYN, right? At this case, if I choose to open the shop, right, then these will be the penalties. But if I chose to close this shop, if I chose to close this shop, then these will be the penalties. That is 2. That is 2. If I choose to open it or close it, while closing it, it will have the penalty of 2. And if I say that, okay, let it be, if I say to open it, then it will count the penalty for if we have n here and if we have y here, right? It will look for n in this side and it will look for y in this side if I want to close it, right? And that will be my total penalty. So I need to calculate the total penalty, and that will be equal to the left side n and right side y. Fine. So for that we need open penalty and close penalty. So open penalty will have the values of n and close penalty will have the value of right side y. So which is why it's initialized with so if the first character is n, then the value will be added. Otherwise, for close penalty of the last character is equal to, so if c of n minus y is equal to a y character, right, then it's 1, otherwise it's a 0. And then I will start filling these values. So first value is 1. We are going to fill the value of open penalties, and we'll do this, and open penalties of ith value is plus equal to open penalty of I minus 1, the previous value. And if the current value is equal to a n character, which means it's a closed sign, then add 1, otherwise add 0. Similarly, for I is equal to n minus 2, I is greater than or equal to 0, and I is decrementing, we will have close penalty of I, that is plus equal to close of I plus 1 plus of c of I. If it is equal to y, then 1, otherwise 0. And then we are going to calculate the total penalties. So I is equal to 0, I is less than n, I plus plus. Now total penalties of I is going to be equal to, and let's say we are also calculating the answer that is initialized with minus 1 value, or let's say it's initialized with n value, or let's say just int max value, right? And so the total penalty will be the sum of the left side penalty, right, and the right side penalty. So left of n and right right side y penalty. So it will be open penalty of I. So open penalty of I will be depending on certain things, but let's just say close of I, because we don't want to subtract anything, because if they are, let's say if we have, so in this example, right, in this example, so if we have y here, then we are counting the current y, but if we have n, then we are not counting the current n. So this is a very important observation. So for that I will say that close penalty of I as it is, and open penalty, if open penalty is equal to n, right, then if open penalty is equal to Yeah, not the open penalty. If the current value of the string is equal to n, right, then open, because in open penalty I'm taking the current value, but I don't have to take the current value. So I will say I and -1 value. Otherwise, open of I as it is, right? So this is the yeah, right. Now I have int max penalty, and that is equal to int max as well. And let's say answer is initialized with 0. Now if the, sorry, minimum penalty, it should be minimum penalty. And if we have a minimum, so let's say the total penalty, the encountered penalty is less than the minimum penalty. In that case, minimum penalty will have the answer, will have the updated value with total penalty, and answer will be equal to ith value. And at last we are going to have our answer. Okay, so it should be open penalty, and okay, so it will have a problem here as well. Okay, so total, okay, total penalty of I. Okay, so these are the example. Let's run them on some simpler examples. I think it's good. Let's submit it, and it's accepted. So this was the problem, and I think there could be a like in the space part, we really don't need the, yeah, we really don't need the that part. We can also fix it by using some variables. We can also fix it by using only variables, like keeping the count of the y and n. And for example, if we are traversing in this direction, we can keep the count of the n. And we can yeah, but first of all we need to keep the count of the total y's, and the number of y's that we have faced will be subtracted with the total y's. So total y's will be minused with um, the current y that we have faced, and they will give us the value of future y. And the past n will be counted as in the iteration, so while we are iterating from 0 to n. And in that case we can reduce the usage or using of these open and p character. We can actually, we don't even want to use this total p as well. So let's say this is int total penalty. Come on. Whoa. Okay, and yeah, let's reduce them as well. So let's keep a count of total y that is initialized with 0, and instead of forming these characters, I will say for loop I is equal to 0, I is less than n, I plus plus, and total y is plus equal to c of I is equal to a y, then 1, otherwise 0. So these are the total y's value. And for close value, what we will do is, and then we have n's, and this is initialized with 0, right? For total p we have n's plus of future y's. right? These are the two values. So n's will be calculated here. So n's plus equal to, if c of I is equal to a n, then 1, otherwise 0. And future y's are calculated as, so for example we have, yeah, future y's will be calculated as, so the number of y's that we have faced till now, yeah, we will also have y's, and that is equal to 0. So the number of y's that we have faced till now will be up here. So n y's is equal to c of I, c of I is equal to y, then 1, otherwise 0. And now future y's will be equal to, yeah, so the previous y's that we have encountered minus the total y's. So total y's, so total y minus uh yeah, the previous ones. So they will give us the future y's value, but we don't want to subtract the current value, which is why we'll be keeping them at below. And yeah, y's, and this will give me the future y's. I'm not sure if this will work, but let's see. It is working fine till this point. Okay, okay, it's working fine. Let's submit it, and it's accepted. Okay, yeah, it's a, okay, it's still not a very optimized one. Yeah, I'm doing the same thing. Oh, okay, that's a good solution. But anyways, so this was the problem, and yeah, thanks for watching, guys. Bye.